jumping into chapter 4, lesson 7. This is law of sine and law of cosine. Some of this stuff you have maybe seen before in geometry a little bit. Some of it is new. There are a couple other formulas that we'll talk about in this chapter, but it won't be until towards the end. So today we're just going to look at examples 1 and 2. Examples 1 and 2 are just law of sine. So the first concept you will see that's on the screen is law of sine. Law of sine is basically just saying that sine A, so the capital letters are all in reference to the angle measure, and then the lowercase letters are all in reference to the side length. So sine A over A is equal to sine B over B, and then sine C over C are all equal to each other. So these are when we're kind of getting into triangles that don't have a 90-degree angle measure, which earlier we did everything that had a 90-degree angle measure, but these necessarily don't, or necessarily do not. So pay attention to the fact that the letter of the angle and the letter of the side are across from each other. So like A's are across, B's are across, C's are across. They're not always going to be labeled, so that is something you need to make sure that you have paid attention to. So jumping into example 1, obviously we know it's not a right triangle. It's not 90 degrees. If we were to find that missing side, which we will in a second, not going to be 90 degrees. So for this question, I know law of sine was A, B, and C. This says L, M, and N. If you need to literally change the letters to A, B, and C so you understand it, you are more than welcome to do so. I'm going to leave them as L, M, N. It's the same concept. They're all just still set equal to each other. So this is asking you to solve the triangle, meaning anything that is not a number that's given to you needs to be a number. So I know angle measure of M, angle measure of L. I need to find angle measure of N. That one's easy. We'll talk about that in a second. I know side length L, but I don't know side length N or side length M. So there are 3 things given to me and then 3 things I need to find. So the easiest thing to start with is my missing angle measure. So we've talked, a triangle always adds up to 180. So that's true no matter if it is a right triangle or if it is some other form of triangle. So the first thing that we're going to do is add your 112 and 29, which will give you 144. Then I'm going to subtract that from 180 and get my missing side length. So whenever I do that, I get that my missing side length, or not side length, angle measure for N is 39. So that's one of the things that I'm trying to find. So I know capital N specifically is 39 degrees. So that's one of the things I need to find. I need to find side length of N and then side length of M. So those are my 3 pieces that I need to find in order to solve my whole triangle. Okay. So for these questions, I know everything for L, meaning I know the angle for L, I know the side length for L. Then for my other 2 sides, I know the angle measures and I don't know the side lengths. So the way that I'm going to set this up is using L as kind of my basis. So I would have sine of my angle L, which is 29, over my side length of L, which is 22. So my law of sine formula is really just sine of the angle measure over that same side length is equal to sine of another angle measure over the side length. So it really doesn't matter which one you start with. I'm going to start with N just because that's what I wrote next over here. So I know that I have sine of 39 for n. So this is my L information and then my n information. And then I don't know what side length n is equal to. Now I'm solving for n. So whenever I solve something that looks like this, I'm cross multiplying. So I would end up with n sine 29 is equal to 22 sine 39. So my 22 is going here and my n is being here. Remember, your side length needs to be in front of your sine and your angle measure needs to be behind your sine whenever you're doing these types of problems. So now if I'm trying to get n by itself, this is multiplication. So I would need to divide by sine 29 on both sides to get n by itself. Then I'm going to plug that whole chunk into my calculator. So 22 sine 39 divided by sine 29 to solve what n is. For these questions, it tells you to round your side length to the nearest tenth, so just one decimal place, and it said round your angle measures to the nearest degree, which would just be whole number, which we already did. So whenever I plug this into my calculator and I solve, I should get that my side length of n is 28.6. Now that I know that piece of information, I could use n to help me set up and solve for m. You could still continue using L to solve for m. That's really up to you. If I have information that's given to me, so like sine of L, the angle measure and the side length was already given up front, like I didn't find that. So if I use that, there's less risk of me being wrong since those two pieces of information I know for sure, versus using something that I found, which in this case is correct. However, I would start with the thing that you actually know for certain because it was what was given in the problem. So I'm going to set up this similar to the last one. So I have sine of angle measure L, which is 29, over my side length, which is 22. Now I am solving for m, specifically side length m. So my angle measure for m is 112, and then my lowercase m for my side length is what I'm solving. So I'm going to set this up the same exact way. I'm solving the same exact way. So I'm cross multiplying. So I would have m times sine 29 is equal to 22 sine 112. To get n by itself, I'm going to divide by sine 29 on both sides. And then I'm going to plug this whole chunk into my calculator and solve for what m is equal to. Whenever you do that, you should get that m is equal to 42.1. So that is your answer to example 1. So again, whatever you're missing, whether it's angles, side lengths, is what you are solving for and trying to find. So generally, you'll be given 3 things. It may be different 3 things. So this is like the AAS, was that you were given an angle measure, and a side length. So sometimes you'll be given that. In example 2 that we're going to look at in a second, you're going to be given an angle, a side length, and an angle, which is similar. It's just in a different format of how it is given to you. So if you want to try the guided practice for yourself, you are more than welcome to. I'm not going to go over it. It's the same concept. You would find your missing angle measure first. So find the missing angle for y. They need to add to 180. You know your information. So this side is x. So you know your angle of x and your side length of x. So that would be your starting point. You would use that to then solve for y and z. So if you want to attempt this and know how to do it, the correct answer is A if you want to work it out. So looking at example 2, example 2 is also a law of sine question. It gives you a word problem. And then there is a figure kind of drawn out to help you understand the actual situation. So it says the angle of elevation from the top of the building to a hot air balloon is at 62. So that would be this side right here. And then the angle of elevation to the hot air balloon to the top of the second building the angle of elevation to the hot air balloon from the top of the second building that is 600 feet due east is 49. So this is my 49-degree angle, and then the distance between the building is 650 feet. It is asking you to specifically find the distance from the hot air balloon to each of the buildings. So I'm trying to find X and Y. In doing that, it doesn't specifically ask you to find the angle measure of Z, but the only side length that I'm given is Z. So I really need the information for Z to be able to find my other missing sides. The reason I say that is I know the angle measure for Y. I don't know the side length for Y. I know the angle measure for X, but I don't know, for X, but I don't know the side length for X. So if I were to set them equal to each other, I'd have two missing side lengths, which doesn't help me. So I need to use the side length from Y and then the angle from Y to actually be able to solve this. So my first step is going to be solving for this missing angle, so I can use that as my starting point. So again, adds to 180, so I would add 62 and 49, and then subtract that from 180. Whenever I do that, I find that the angle measure of Z is 69 degrees. So setting this up similar to the last one, I'm going to use Z as my base. So I would have sine 69 over the length of side Z, which is 650. It doesn't matter which one you solve first. I'm going to solve for X first for no reason. I know the angle measure for X, and remember they're opposite or kind of across from each other, is 49. I don't know the side length, so that's what I'm trying to find. So I'm finding side length for X first. Then I am cross multiplying, so I would have X sine 69 is equal to 650 sine 49. Then I'm trying to get X by itself, so I would divide by sine 69 on both sides. Plug that whole chunk into your calculator again, and it doesn't tell you this in this question. Common rule, just round to one decimal place. So whenever you solve, you would get 525.5 for your X value. I also need to find my Y value because it tells me to find the distance from the hot air balloon to to each of the buildings. So far I know that this is 525.5, but I need to find side length of Y. So I'm going to do the same thing. I'm going to use Z again to set up. So sine 69 over 650. You can use sine X now that you know it. So you could use sine 49 over 525.5. Because it's a decimal, it might be off a couple places whenever you go to solve it. Again, I would always use the one that's given to you to start with. So now I'm trying to find side Y. So angle for Y across from it is 62. And then I need to find my missing side length of Y. When I cross multiply, I'm going to end up with Y sine 69 equals 650 sine 62. To get Y by itself, I'm going to divide by sine 69 on both sides. And so now I have 650 sine 62 divided by sine 69. I know it's kind of hard to read. Again, I'm going to plug that whole chunk into my calculator. When I do that, I will get that Y is equal to 614.7. So this is this side of your building. So you found side length for X and then side length for Y. So that is where we are going to stop today, is with example 1 and example 2. Tomorrow we will look at example 3, part A and B, and then keep moving on.